Hi everybody, in this video we're going to go to 7th grade and then L and then over here where it says new. Okay, so L and then new, solve percent problems using strip models. All right, so read the problem, that's always a good idea. The Sweet Dreams Hotel has a total of 125 rooms. If 25 are vacant, which percent of the rooms at the Sweet Dreams Hotel are vacant? Pick the model that represents the problem. Okay, so first of all, it's telling us that the total number of rooms in the hotel is 125. So 125 should correspond to 100% because that's all of them. That's all the rooms they have. And we can see that in both of these strip models here, 125 does correspond to 100%, okay? So both of these models are telling us that 125 is all of the rooms that are in the hotel. So we still don't know which one of these are correct just from this number. Let's look at this number over here. If 25 are vacant, what percent of the rooms at the Sweet Dreams Hotel are vacant? So now 25 is not a percent, that's a number of rooms. So it should go in the same part of the strip model where the 125 is, because 125 is also a number of rooms. So for this model over here, 25, well, here's what I mean by that, in case that was a little bit confusing. I can see that in this model here, the percentages are at the top. Okay, we have 0% on the top, and we also have 100% on the top. And we have the number of rooms on the bottom, okay, 0 rooms or 125 rooms. And it looks like it's the same for this model over here. On the top, we have the percents, and on the bottom, we have the number of rooms. So 25 is not a percent, that's a number of rooms. So it should be going on the bottom of both of these strip models, and it looks like it is going on the bottom. Okay, so we still cannot decide which one of these strip models is correct based on if 25 is in the top or bottom, because it's in the bottom for both of them like it should be. All right, now here's what we can do, however. Notice that from 0 to 25, from 0 to 125, it looks like this has been broken into 1, 2, 3, 4, 5 pieces, with 25 being at the end of that first piece there. And down here, the number of rooms from 0 to 125 has been broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, with 25 being at the end of that first piece. Now, if we were to continue this one, so if each of these boxes is like 25 rooms, so 0 plus 25 is 25. If we add another 25, then we would get 50. We add another 25, we get 75, and then 100, then 125. We see that 125 should be over here, not over here. So this 25, even though it's in the bottom like it should be, it looks like it's a little bit too close, proportionally speaking, to where 0 is. It shouldn't be that close to 0 and that far away from 125. Whereas over here, 25 looks like it's in just the right place, because here's 0 plus 25 is 25 plus another 25. If we just keep counting by 25s, then we'll see that this would be 50 and then 75 and then 100, and then 125 is exactly where it should be. So this makes sense, having 25 here, not over here. So this model is correct, all right? But now for this IXL exercise, they also want you to figure out what that should be, okay? So, well, and there are a couple of ways that we can do it. This is what I would call a find the percent of the whole problem. And to answer a find the percent of the whole problem, we would just do the part, which is 25, divided by the whole, which is 125, and then we'll get a decimal, and then we just convert that decimal into a percent. And you can use a calculator for that. Make sure that you're not doing the whole divided by the part. You're doing the part divided by the whole. So 25 divided by 125, that would give us 0.2. And then if we take 0.2 and we just move the decimal point 2 spaces to the right, 1, 2, okay, then we would put a 0 in that blank space, so that would be 20% as a percentage. Okay, so the answer here is going to be 20%. Remember, anytime it's asking you to find that percent there, then you would take the part and divide it by the whole, and then just move the decimal point 2 spaces to the right. But there is actually another way that we could have figured out that this was 20%, because we can see here that, like we said before, this model here has been broken up into 5 pieces, 1, 2, 3, 4, 5. So if this is 100 over here going from 0 to 100, if I take 100 and I divide it by 5, I would get 20. And then I would just keep counting by 20s from 0. Okay, so 0% plus 20% would be 20%, all right, which is exactly where the question mark is. So I already have my answer. But let's just say, as an example, if the question mark had been over here and I was wondering, okay, what would that question mark be? I would just keep counting by 20s. 20, and then 40%, then 60%, and 80%. So if the question mark had been over here, then I could just count by 20s until I got up to here, and I would see that 100, what this is telling me is that 100 is 80% of 125. But that's not what we wanted to answer for this problem. We wanted to know 25 is what percent of 125, and we already found our answer. 25 is 20% of 125. All right, so I put it in there already. Let's submit there. Okay, Jake's coupon took $2 off the price of a book. If the coupon took off 10% of the price, how much did the book originally cost? Pick the model that represents the problem. All right. How much did the book originally cost here? Okay, so what we want here, if it's asking us for the original price, then that original price would correspond to 100%. So this model over here, where the question mark is corresponding to 100%, that's the model that we're going to pick here. We have over here in this model, if 2 corresponds to 100%, that's telling us that the full price of the book was $2. But that's not what this problem is really saying. The full price of the book is not $2. $2 is what was taken off the price of the book, and also as a percent, it was 10% of the price of the book that was taken off. So really, $2 is 10% of the full price of the book. So that's what this model is telling us, which is that $2, we can see here in this model, we have the percent. All the percents are in the top here, and the price, or the price in dollars, is on the bottom here. So what this model is telling us is that $2 is 10% of the original price of the book, okay, of the full price of the book. So this is correct over here. What this one would be saying is that the full price of the book was $2, and maybe 10% was taken off, and we wanted to figure out how much was taken off as a dollar amount instead of as a percentage. But that's not really what we want to know from this problem. Okay, so this is the model that we're going to use. And this is what I would call a find the whole problem. And that might sound a little bit confusing for those of you, I don't know who's watching this on YouTube, but for those of you who are in my class, you might think that I would classify this as a find the original value problem, because we do want to know the original price of the book. But it's not, because $2 is not, it's a little bit tricky, but $2 is not the new price of the book. That's just the part of the price which was taken off, and then we have to figure out the whole price. So it's a little bit tricky, but this is actually not what I call a find the original value problem. This is what I would call a find the whole problem. And to do that, we would take the part, which is 2, and divide it by the percent written as a decimal. So 10% written as a decimal. Here's the decimal point here. We just move it 2 spaces to the left, so it would be in front of the 1. Okay, so we were just going to do 2 divided by 0.1 or 0.1 if you like, and that's just going to be 20. Okay, so the original price, or the full price of that book, is $20. Okay, and another way that we could have figured out using this model over here is to notice that from 0 to 2, well, that's easy. That's just an increase of 2, right? So we could just keep counting by 2's here on this model. 2, and then if we add another 2, we'll get 4 over here, and then if we add another 2, we'll get 6, and then 8, 10, 12, 14, 16, 18, and look at that, 20. Okay, so same answer that we got using this over here. All right, so remember, this is if I'm looking for the whole here, and I know the part, and I know the percent over here, then I just take the part and I divide by that percent written as a decimal, and that'll tell me what the full price is, or whatever it is we're talking about, the full number of people in a movie theater, or whatever the problem is about. Okay, so put 20 over there. Now let's try another problem. Maybe we'll do 2 more, let's say. Read the problem. 10% of the passengers on a Fly With Us Airlines flight are in first class. All right. Well, I can see already that this is a problem over here, because this 10 is a percent, right? It's not the number of people. So I can see that on these models here. In the top again, we have the percent. And it looks like in the bottom here we have number of people. Let me just change the color to do the other one. Right, in the top we have the percent. In the bottom we have the number of people. All right, I can see that 10 has the percent symbol next to it. 10 is the percent of the passengers on a Fly With Us Airlines flight. It's not the number of people. Okay, so it shouldn't be over here in the people section of the model. It should be over here in the percent section. So already I can see that this model describes the problem better than this one. Okay, so 10% of the passengers are in first class. If there are 40 passengers in first class, how many total passengers are on the flight? Okay, so 40 is not all of the passengers on the flight. So 40 would not correspond to 100%. Not every passenger on that flight is in first class. 40 is only the number of people who are in first class, which is 10% of all the people on the flight. Okay, so this model represents what's going on in the problem. And this is another of what I would call a find the whole problem. So what we're going to do is we're going to take the number of people here, or take the part, and divide it by the percent written as a decimal, which would be 0.1. And that's going to give us 400. Okay, so this would be 400 over here. And another way we could have figured that out using this model is to just, looks like we're counting by 40s here, right? 0, 40, then what would be next? 80, 120. I'm just going up by 40 each time. 160, 200, 240, 280, 320, 360, and then 360 plus 40 would be 400. So it all works out. All right, so there are 400 is the total number of passengers on that flight. Only 10% of those passengers are in first class, which is 40 passengers. Okay? If I had been going the other way, if I had been given the total number of passengers and I was told that 10% are in first class and I wanted to know how many people that was, then I would have done 400 times 0.1 equals, and in that case it would be 40. Okay, so if we're given the part and the percent and we want to find the whole, then we divide. If we're given the whole and the percent and we want to know the part, then we would multiply. Okay, so submit there. Let's do another one here. Read the problem. I guess too many students have been trying to do their IXL without reading the problem, so now I have to remind you. 30% of the toys collected at the holiday toy drive were stuffed animals. There were a total of 80 toys collected. How many toys were stuffed animals? Okay, so 80 is the total. Again, there were a total of 80 toys collected. So that means that 80 should correspond to 100%. That was all the toys. I can see in this model, 80 does correspond to 100%. In this model, it does not correspond to 100%. So 80 is not the number of stuffed animals, okay? 30% of all the toys collected were stuffed animals. 80 should not be corresponding to 30%, which is only the stuffed animals. 80 is not the number of stuffed animals that were collected. 80 is all the toys that were collected. So 80 should correspond to 100%, like in this model here. And what we're trying to figure out is how many of those 80 toys were stuffed animals. Okay, well, we know that 30% of the toys collected were stuffed animals. So what we want to know here is what 30% of 80 is. Okay, and again, this is what I would call a find the part problem. So we would do the whole multiplied by the percent written as a decimal, which would be 0.3. Okay, so we're going to multiply to find the part. If the question mark had been over here, then we would do 80 divided by 0.3 to find the whole. But if we're looking for the part, then we multiply, and we would get 240 there. I'm sorry, not 240, 24. Okay, so that means that only, so 24 out of the 80 toys collected were stuffed animals, and 24 is 30% of 80. Now, another way that we could have solved this using the model over here is to think, we could reason this way, okay? So this, from here to here is 80, right? And it looks like this has been split up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes, all right? So what's 80 divided by 10? 80 divided by 10 is 8. So that means that we're going to count by 8 to figure out what goes on the bottom part of all these lines over here. So 0 plus 8 is 8, plus another 8 is 16, plus another 8 is 24. And notice that's the same answer we got before. Plus another 8 would be 32, and then 40, 48, 56, 64, 72, and then 80, right? Okay, so we're just counting by 8s, and we can see that where the question mark is would be at 24, which is the same answer we got before. All right, let me see if I want to do one more problem here. Jamal bought a package of 50 water balloons and used 35 of them with his friends. What percent of the water balloons did Jamal use? Okay, so it looks like I'll do this last one. This is what I would call a find the percent of the whole problem. So we're looking, this question is asking us what percent of the water balloons did Jamal use? So the question mark should be in the percent part of the model. And it looks like for both of these models, the question mark is in the top of the model, which is where the percents are. So far, I can't rule out either one of these just by looking at which part of the model the question mark is, because it should be in the percent part, and it is in the percent part for both of them. So how else can I rule out one of these models? Well, I know that 50 is all of the balloons that Jamal bought. So 50 should correspond to 100%. All right, and it looks like in both of these models, 50 does correspond to 100%. So I still can't rule out either of the models. And let's see about this. 35 of them, and he used 35 of them with his friends. So 35 is the part, and it looks like 35 is also in the correct part of the model for both of these. It's in the bottom, which is where the balloons are, right? So at the top here, we have the percent. In the bottom, we have the balloons. Okay, so it looks like the 35 is in the bottom part, which is where the number of balloons are. So I still can't rule out either of these models with that sort of reasoning. These models look very similar, actually. The 50 corresponds to 100. We have the question mark over here, right? We have the 35 beneath the question mark. So they look very similar. But here's what we will do to reason out which of these models is correct. We're gonna reason this way. Okay, if this is going from 0 to 50, and it's been broken up into 1, 2, 3, 4, 5 boxes. So let's do 50 divided by 5, which is 10, and that means that all of these should be counting up by 10. So 0, 10, 20. This should be 30 over here, not 35, 40, 50. Okay, so this is wrong over here. Let's just double check that this one is actually correct. This one from 0 to 50 has been split up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So 50 divided by 10 is 5. So all of these should be going up by 5s here. 0, 5, we're just counting by 5s, right? We keep going up by 5, up by 5, 5, 10, up by 5 again, we would get 15, 20, 25, 30. It looks like 35 is in exactly the right place here. 40, 45, 50. Okay, so this model is definitely correct. And then this is a find the percent of the whole problem. If I'm looking for the percent here, what I'm going to do is I'm going to take the part and divide it by the whole. All right, so we would take, and then that's going to give us an answer as a decimal. All right, and then we're just going to convert that into percent form. So we would do 35, which is the part, not the whole, divided by the whole, which is 50, and that would give us 0.7. Don't believe me? You can do it in a calculator. Make sure that in your calculator you're typing in the part first. If I were to do, what's going on here? Not responding. Give me a second. If we were to try to do the, really? Okay, never mind. Anyway, just remember to put the part first in your calculator. Okay, so that's going to give us 0.7, and then we can move the decimal point 2 spaces to the right, and we could put a 0 in that blank space. The new decimal point would be at the end. And then, but I don't really have to write the decimal point at the end, so I'm just going to erase that and write 70%. Okay. So Jamal used 70% of the 50 water balloons with his friends, okay, and that was 35 water balloons. All right, let's see if this problem is different from the ones we've done already. 20%, there's no other level here, so these should all be pretty similar. Let me see if I want to do this one. 20% of 6th grade students are in the engineering club. If 24 students are in the engineering club, how many 6th grade students are there in all? All right, so 24 is not the total number of students. 24 is just the number of students in the engineering club. Okay, so 24 should not correspond to 100% like it does over here. 24 is just the students that are in the engineering club, which is 20% of all the 6th grade students. All right, so this model describes what's going on. What we're looking for here is all the students that are in 6th grade, okay? How many 6th grade students are there in all? Not just the engineering students. So this is a find the whole problem. To answer this, we would do 24 divided by 0.2, which is 20% as a decimal point. So as a decimal. So if we do 24 divided by 0.2, that's going to give us 120. All right, and another way of figuring that out using the model over here would be to say, okay, from here to here, so I guess this is a little bit different just because we didn't have a problem where we had to figure out what we're counting by based on the part over here. We always did it by the whole. So based on the part which was given to us, from 0 to 24, there are 2 boxes between them. So 24 divided by 2 is 12. So it looks like we're counting by 12s each time. So 0 plus 12 is 12, plus another 12 is 24, so that works. And then 36, 48, 60, we're just counting by 12s over here. 96, 108, and 108 plus 12 is 120. Okay, so that's another way we could have figured out that answer. All right. 60 students in the school orchestra, 20% of them play the cello. How many students play the cello? So this is a find the part problem. 60% is not 60% is, I'm sorry, 60 is all the students that are in the orchestra. Only 20% of them play the cello, and we want to know how many students play the cello. So we're trying to find, that would be this one over here, and we could do that by 60 times 0.2 would be 12. Okay, so that would be that one. Could have also solved that a different way using the model itself. I think we've done enough problems here, so I'm going to end the video there. Hope that was helpful, and have a great day.